Hi, everyone. Thank you for joining the webinar. My name is Vikram, and I work for GL Communications. This webinar we are very excited to talk to you about is on our high-speed capture and analysis of VoIP and wireless protocols over IP. I'm joined on this call with two of my colleagues, our senior engineers, Mike Yang and Sanjeev Jigajini. They are the ones that have helped design and build this incredible system that we're going to talk to you about today. Our company, like I mentioned, we are GL Communications. I think most of you are already familiar with us, but in case you're not, we are headquartered in Gaithersburg, Maryland, United States. That's also where we build and manufacture all of our test and monitoring equipment. We ship and from our headquarters location as well. We've been around for over 35 years now. We do consulting services, and we also manufacture test and measurement equipment. And our focus is the telecom industry. We manufacture test and measurement equipment for all sorts of different telecommunications networks. Everything from your old analog public switch telephone network all the way through TDM to Ethernet, fiber optic, wireless, 2G, 3G, 4G, 5G, land mobile radio, basically the full scope of telecom networks out there. We provide test equipment to interface to those networks, capture on those networks, monitor, emulate traffic on those networks, and perform measurements. So I think what sets us aside from the rest of the competition is the fact that we have solutions for all of these different types of networks. So today what we want to talk to you about is specifically high-speed capture and analysis. So when I talk about high speed, we're talking about Ethernet and IP networks at up to 100 gigabits per second. We are also soon going to release a 400 gigabits per second test device, but for today we'll stick to 100 gigabits per second. So these ultra-fast links are being found in backbone networks. They're also being found in data centers and between data centers, and so on. So as the world continues to evolve to higher and higher speeds, we have also evolved our test equipment to test at those high speeds. Now, when you want to capture traffic on such high-speed networks, first off, you want to do so without any loss. You don't want any packet loss, and you also typically you want to look for certain types of traffic, because otherwise it's so much traffic you don't really care for looking at the whole thing. You may just want to filter on certain types of traffic, different IP addresses or protocols, ports, payloads, and so forth. You want to do some deeper analysis on that type of traffic. You want to look at the throughput. You want to look at packet loss that's occurring over the network. You may want to look at certain applications that are using the most bandwidth. You may want to look at security incidents, rogue connections, and things like that. You may, if you're specifically interested in VoIP, you may want to do VoIP analysis. So think about call centers and so forth. So in terms of call analysis, we can intelligently build the call detail records, compute a whole host of metrics on the calls, including voice quality and other key performance indicators. We can perform surveillance, and we can do long-term storage of all these captures. A lot of customers need a centralized web-based dashboard that they can kind of remotely log into and view all the data. So that's a key requirement for a lot of customers. Some customers need a portable solution, something that they can take out into the field, connect into the network, do their analysis. unhook from the network, go to the next site, and repeat. So some customers need portable solutions. Some customers need rack mount solutions where they just stick it in one server room or one lab and leave it there. So different customers have different requirements in terms of portability. And then also a lot of customers ask to be able to play back traffic. So once you record the traffic, you may want to play it back. And the reason you would want to play it back is you want to test certain applications or infrastructure to see how they're handling that traffic. So these are some of the points that we often get asked about from our customers, and these are a lot of the requirements that are asked for. Okay, so when we say HD in the rest of this presentation, we're talking about high density, meaning the ability to capture at ultra fast rates. We're going to talk about a specific product of ours called PacketScan HD. I'll get right into it on the very next slide. It has a lot of incredible capability. It also comes with these two optional applications, FastRecorder and PacketExtractor. We'll talk about that as well. And if we have time, we'll talk about NetSurveyorWeb, which is the centralized dashboard. Okay, so this is our main system. Here on the left-hand side is PacketScan HD. Here we're showing the portable version, but again, we also have a rack mount version. I want to emphasize that this system is totally customizable in terms of what data rates you want to capture at, in terms of the RAM, in terms of the storage, you know, how many cards you need, how many network interface cards, and so forth. So we can go from just, you know, we can capture on, you know, simple gigabit Ethernet networks, or we can go up to 100 gig Ethernet networks. We can take the RAM all the way up to 128 gigabytes, and we can provide a ton of long-term storage. If you are capturing at super high rates, you will fill up your storage quite quickly, which is why we can actually stick up to 8 NVMe SSDs into a single system to give you plenty of storage. Also, with this system, it's a completely custom-built solution. So we've optimized the cooling, we've optimized the disk write capability. We make sure that the system can capture and record to disk without loss indefinitely. So what happens is, even if you go beyond the limit of the SSD, you can set a condition where it will simply rewrite the previous files that captured and so forth. So you can actually capture indefinitely. Also, this system is built to last. It's durable. It won't overheat. It won't crash on you. We have literally let this system run for months on end. Customers use it for months on end. No issue at all. So it's totally custom built. We also put it in a nice Pelican case, and so you can take it around. It's got wheels. It's got slots to hold all the accessories and SFPs and cables and things like that. So it's a complete solution. Yeah. Oh, okay. Here. So here's the rack mount version. So again, depending on how many network interface cards and how much horsepower you need, we can supply you with either a 2U rack mount system, or we can go up to a 4U rack mount system. So here you see a 4U system, which has 4 network interface cards, and they each have 2 100 gig Ethernet ports on them. So it's a very powerful system. Okay, now we can also mix and match in terms of the data rates. The switch is processing traffic over the network, and you can set up monitor ports on the switch, and you can aggregate multiple 10 gig ports and feed them into PacketScan HD, into the two 40 gig ports. And then on the PacketScan HD system, that's where you do your analysis. So this is how we interface to your network. We do it through multiple monitor ports on a switch, whether they're 10 gig ports, 40 gig, 100 gig ports. It doesn't matter. With the right cables that we provide you, you'll be able to monitor all the traffic going across that switch or that network. You can also interface through a network tap. That'll work as well. But typically, if you want to monitor multiple traffic flows, you typically use monitor ports on a switch rather than a network tap. So this is how we connect into the network to capture all the traffic. So with this PacketScan HD system, there's multiple slots here where you can put additional network interface cards. Capturing at all these different data rates, 10 gig, 25 gig, 40 gig, 100 gig, they all have different SFPs. They all have different cables and connectors, single mode, multi-mode, breakout cables. I mean, it just goes on and on. But the bottom line is we support it all. We can provide it all. Okay, so that's the hardware platform. Let's dig a little deeper and talk about these two applications, FastRecorder and PacketExtractor, which are used to do this high-speed capture operation. So first off, like I mentioned on the previous slide, we connect to the monitor ports on a switch. We feed it into the PacketScan HD system. Now, the PacketScan HD system can do continuous, lossless, error-free packet capture, and we will talk about the PacketScan software in a little while. It comes with our proprietary PacketScan software, so in real time you'll see all the information showing up on the screen, all the packets and everything. We have nanosecond timestamping capability. A lot of our customers these days are asking for very precise timestamping. They're looking for specific events taking place on the network. We support nanosecond timestamping. So every packet that comes in, we timestamp it at nanosecond precision. Okay, the next bullet, wire speed hardware filtering. Now, you may not be interested in all the traffic going across the network. Maybe you're probably just interested in a subset of that traffic. So we can, at the hardware level, filter on different types of traffic, IP addresses and protocols and things like that. And because we're doing it at the hardware level, right at the network interface card, there's no loss. It's not being done by the OS. There's no delay. It's all being done at the hardware level at the onboard network interface card. So that's the advantage of doing it at the hardware level. So you'll do the filtering operation at the hardware level, and then just focus on the packets that you're interested in. Packet slicing. This is the idea that maybe you don't need the whole packet. Maybe you just need the headers, or maybe you just need the payload, or something like that, in order to save space. So we can do packet slicing. We support IPv4 and IPv6, and then time synchronization for co-located. Okay, let's say you have multiple PacketScan HDs deployed in a location, all capturing traffic. You can actually synchronize the timestamping on all of the PacketScan HDs with a simple SMA cable, so that all the PacketScan HDs are synchronized to the same timestamp. This is a specific capability that we've implemented. One customer in particular needed multiple of these systems in the same place, but needed the same exact timestamp on each system, so we did that. Okay. Yeah, so FastRecorder can actually record up to 320 gigabits per second. So we have multiple network interface cards, right? We have multiple 100 gig ports and 40 gig ports and so on and so forth. FastRecorder can record from those multiple ports and it can write to disk at up to 320 gigabits per second. You will not lose any packets. So now we can build the system with up to 240 terabytes of total storage. We put a lot of SSDs into that system, and so that way, you know, you can, if you really need to record lots and lots of traffic, you have the space to do so. In terms of the disk operation and the distributed disk writing and all that stuff, we've optimized all of that. So we are actually recording to several disks simultaneously. So here in this snapshot, for instance, you see D drive, F drive, G drive, H drive. We're actually writing to all of the disks simultaneously, and we are able to do so without loss. You can set all sorts of conditions. You can stop the recording after a certain file size, and there's other features that we'll talk about shortly. You can define which ports you're capturing over. It's all possible, and then with a click of a button, literally just start recorder, it'll just start recording. The graphical user interface is very easy to use, and it'll give you basic statistics, how many packets are captured, how many were filtered, how many were dropped, and things like that. You can filter, like I said before, you can filter on all sorts of different protocol headers. So we're showing a snapshot here where we're filtering on IP address. You can do it on VLAN tags. You can do it on MAC addresses. You can do it on UDP ports, TCP ports as well. Okay. I'm gonna go a little quickly through these screenshots. I don't want to bore you too much. But again, when you filter, you can make more complex expressions. So you can combine different filters. You can use logic. So you can say, oh, I only want to capture on this specific IP address on this specific port, or this other IP address at this specific port. And so you can define multiple rules and then use simple logic to define one filter that can cover all of your scenarios. So we support that as well. And multiple filters you can define multiple filters as well. So that's a powerful feature of our platform. GTP, we've had certain customers interested in GTP, so you can put GTP traffic filters. We've had customers specifically interested in eCPRI. We'll talk about that a little bit later, but some of these advanced protocols we can also we've built that functionality into our filtering capability. Okay, so let me keep going. Like I said, we can get all of the statistics on the captured packets. So we can tell you how many filtered frames, how many frames were not filtered, or how many frames were dropped because they didn't satisfy the filter. We can tell you how many gigabytes have been recorded, what's the capture rate, you know, how long the capture has been going on for, and things like that. If there's any sort of failure, we'll report it, so you have all that information. You can also look at each individual port. So like I said, we have multiple ports on the PacketScan HD. If you just need to look at a single port, you can look at the statistics for that single port. We've got all sorts of counters. We can count up the total number of packets of a certain frame size, total number of packets with the certain VLAN tags, total number of packets, you know, all sorts of different things. Okay, you can get real-time graphs. So here we're showing you as a function of time the throughput at which we're capturing at. So you get all these statistics as a function of time. So here we're actually plotting, the rate at which we're capturing traffic over the network, and then we're also showing you the filtered traffic, so just the throughput of the filtered traffic. So as you can see, the filter is filtering out a lot of the overall traffic. So that's why the pink line is below the blue line. So like that, and again, the graph duration, you can plot it in, you can go back many days, weeks, and so forth, and you can see all the data. Okay, now we can also trigger on things. So we can do things like, okay, if a certain packet is detected, send an email or start a recording, or stop a recording, or something like that. So with different types of conditions, we can start the recording, or stop the recording, or send an alert, things like that. So that's very nice. So that means you can just have it connected into the network, capturing traffic. But whenever a certain condition occurs, you can actually start recording to disk. So that's another feature that we've had multiple customers ask for. Okay, now that was all FastRecorder. There is a companion application called PacketExtractor. What happens here, FastRecorder writes out to multiple disks simultaneously, and it writes it out in a very in a compressed, optimized file format. Now, an individual packet may actually be, parts of that may be broken up across multiple disk drives. So what PacketExtractor does is it looks at the recorded traffic from FastRecorder, and it synthesizes it across multiple disk drives and produces a PCAP file for you. So the PCAP file, so that's what PacketExtractor does. It takes the recordings and extracts it into a nice, clean PCAP file, or our proprietary HDL file format. And you can then use the PacketScan software on board the PacketScan HD system to analyze the entire packet capture. So for those of you who are familiar with PacketScan, it's very similar to Wireshark, but much more powerful in terms of metrics, in terms of protocols, and in terms of codecs, in terms of just overall capability for protocol analysis. But usually we also install Wireshark onto the systems, or you can install Wireshark onto the system as well. If you want to use Wireshark, you can. PacketExtractor can extract to PCAP file format, so you can open the packet captures in Wireshark. When you extract the packets, there's a lot of ways you can extract the packets, and from which ports you wanted to extract the packets from, and things like that. So PacketExtractor works after the recording is made with FastRecorder. Okay, so that's how we capture, record, and synthesize all the information into nice, clean packet capture files. Now let's dive into the analysis, what you can really do in terms of analyzing your traffic. We're going to start off with our IP analytics tool. IP analytics, so let's say you're monitoring a network with, dozens or hundreds or thousands of IP addresses talking to other IPs and things like that. IP analytics is great for identifying all that traffic, identifying the different conversations taking place, identifying the total bandwidth used by a given IP address. It can look at quality of service metrics. It can calculate statistics like packet loss and things like that. So yeah, here's where we see everything. it's very good at just synthesizing all the information and summarizing it for you. How many packets were IPv6? How many packets were IPv4? Class of service analysis. Layer 4 protocols. List out all the IPv4 endpoints. It can go higher. It can go to TCP and UDP. So it can tell you all the conversations taking place over TCP and UDP and so forth. The UDP ports, TCP ports. It's just really good. IP analytics is very good for layer 3 and layer 4 analysis, identifying your top talkers on the network and filtering on those conversations, getting all your summary statistics. It's again, this is a built-in tool. Something you can take advantage of. It comes with the PacketScan HD system, and it's probably what you want to do first when you have such a huge packet capture. This is probably the first layer of analysis that you would want to do. Okay, so like I mentioned, we can do layer 3 and class of service statistics. And so forth. So class of service can be, there's different labels for class of service. You can count up total number of packets for that class of service and so forth. Let me go ahead and by the way, if you're unfamiliar with class of service, this is for prioritization of traffic over the network. So certain types of traffic needs to be prioritized over other types of traffic. And that's where these class of service tags come into play. Okay. Yeah, these are just more, I apologize if these screenshots are a little blurry, but these are just more statistics we're showing you, specifically IPv4 and IPv6, because we often get asked, do we support IPv6? So we just wanted to be 100% clear that yes, we do support IPv6. Again, more screenshots. This is TCP and UDP conversations. UDP would be like streaming services, streaming video, VoIP calls, and things like that. TCP would be for web browsing, file sharing, and stuff like and stuff like that. This is how you can start delving into what types of traffic is going over your network. Yeah, we can do filtering as well with the IP analytics tool. So again, once all the packets are captured, we can filter on certain things. Like here, we're filtering on a certain class of service and getting the statistics on that class of service. We've got graphing capability. You can see throughput over time for a certain type of traffic. So here we're showing just the IPv4 throughput over time, both in terms of kilobits per second and packets per second. So we have all this inbuilt graphing capability. We can do, yeah, this is just, again, more layer 3 and layer 4 type stuff, ICMP type statistics, pings, and things like that. And finally, you can export everything to a CSV file. So all of the data that's being calculated, you can export it as a CSV file to that PacketScan HD system. It's a full-blown Windows PC. And so you can just export everything to a CSV file on that same system. Rate analysis, again, this is just more throughput type measurements. Let me go ahead and skip this in the interest of time. Basically, all it's doing is showing you, okay, here is the traffic that was taking place as a function of time. And we look at the precision we have. So this graph is in milliseconds, but we have, like I said before, we actually have nanosecond precision on the timestamping. So you can see the throughput down to the nanosecond level. Okay, At this point, we get asked about specific proprietary, not specific protocols. Often, different companies have interest in different types of protocols. So let me turn it over to Sanjeev Jigajani, and he will talk about a specific protocol, eCPRI, and what we can do with eCPRI in particular. Go ahead, Sanjeev.
Yeah, thank you, Vikram. So here on, we'll be looking into what we provide with respect to the eCPRI analysis. So eCPRI is actually a evolved common public radio interface, which is mainly used in this front haul traffic transport network. So you could see that when we have this radio unit, from there when we would like to transfer to the core network, that the frontal interface, so there we mainly use this eCPRI, which is actually enhanced CPRI module, existing one. So here it is mainly used enabled efficient transmission of this high capacity and low latency data between this the REC and the RE. You can see that radio equipment controller and this radio equipments. We have this base stations. From there, will be transferring data to this the core network or mid haul or back haul. So this will be a very important interface, as it will be very high speed as when we move from 4G to 5G. So we'll be having around 25 Gbps of traffic rate. So it is very important to analyze this traffic because its performance can have a significant effect on overall quality of the services. Like if we have any issues over this with respect to congestion or the loss, latency, jitter, this in turn will lead issues in the overall quality of this service. So analyzing eCPRI is a most important one because of data rate, and nowadays previously CPRI has many very vendor specific. So because of that, now eCPRI for more compatibility and interoperability among many vendors, they have come up with this compatibility option, and also they want to reduce the bandwidth by having a higher compression. So with all these we have an enhanced eCPRI. The meantime, its monitoring and analysis is going to be a very important feature or analysis option. So in our FastRecorder, we have an option to first filter out or filter in this traffic. The eCPRI is mainly carried over MAC or the UDP. So we have a hardware filter option, where if you are interested or to filter out any of unwanted traffic, then I can use this option eCPRI. If you want to capture this eCPRI which is carried over MAC, or it can be over UDP with the specific port numbers. And within that, we have even eCPRI carries different kind of data. For example, it carries actual user data, or it can carry the control information, or it can carry the time and reference signals, like in order to have kind of synchronization, and it carries some alert or alarm or fault information. So we can select the message types among it to filter. Like for example, if you want to analyze only the control signals, so we can even apply the filter at the message level, and then take out only those recording and do the analysis. So that was about filtering, and what we do means why it is required for analysis. So since the main key factors will include the message sequences, whether the messages have been properly received in sequence or no, and the one of the other parameter is delay. There could be a delay, so we have a one-way delay means parameter, which is providing in microsecond resolutions. And also from the message which identifies like some of the events like hardware faults, software faults, or vendor specific faults. So we extract all these parameters from the eCPRI messages and we show them in our analysis like tab or the window, which helps in like troubleshooting this eCPRI interfaces. And it also provides like kind of graphical representations of reset events where it has happened, like and any fault events and any memory access issues, all those parameters which are very important in order to have like performance and reliability of the front haul networks. So we do provide all these important parameters which help them in troubleshooting this eCPRI interfaces. So this is all about like eCPRI. I would like Vikram to continue on the rest of the slides. Thank you.
Okay, thank you, Sanjeev. So I'm going to talk a little bit about the PacketScan software now. The software can decode many different types of protocols. So we list a lot of them here on the screen: 5G, LTE, IMS, UMTS, and so on. SIP, RTP, SIGTRAN, all these different types of protocols. The PacketScan software can decode them intelligently, build the call detail records, save the calls, and so forth. So PacketScan is very good in terms of call analysis, much better than any open source tool like Wireshark. So here I show you some of the supported protocols and codecs. It's a whole laundry list. I won't read them all out loud to you, but again, this is all built into the software. And so when you buy this system, this PacketScan HD system, it comes with this. It's one complete system for both capturing and analysis. It's all, you don't need to go out and buy a different vendor product to install on our product or anything like that. It's all a self-contained system for capturing and analysis over all these different types of protocols. So we can also do encrypted traffic. So now for encrypted traffic, we need the decryption key, obviously. But if you have the decryption key, then we can record all the encrypted traffic and then decrypt it. So we support ESP on both IPv4 and IPv6 and so forth. So here's a little snapshot of that. We do get requests for decrypting encrypted traffic, and so now we've implemented that. But again, of course, we do need the decryption key to do that. Okay, so like I said, PacketScan is very good for call analysis. From the individual packets, it'll build the call detail record. It'll show you the call detail record. You can click on any call. You can get the full call setup, tear down, the whole ladder diagram, the whole decode of the call. It's all here. You can save the call. You can play back the call. It's all there. It's all doable. We can also do fax. So you see down here it says T38 analysis. We can do fax over IP analysis with the PacketScan software. The nice thing about our software, we can do triggers. We can trigger on certain things and do follow-up actions. This is something that you can't do in Wireshark. So when certain packets are detected, or a certain voice quality score is made, or certain types of statistics are determined, you can then create an alert, or send an email, or print to the screen that this condition has happened. And you can do follow-on actions. You can save that packet or that call to a PCAP file. You can export the report. You can export the data to a CSV file. You can record the audio. You can extract, if it's a fax analysis, you can extract the fax image. So based on certain conditions that you set, you can define follow-on actions. Okay, I detect an incoming fax, extract the fax image. And so it'll automatically do all that for you. So that's the nice thing about the PacketScan software. Another example, okay, maybe, I see a call that came in with a very low voice quality score. Okay, let's save that call, let's save that whole CDR, and that way we have it for future analysis. Like I said, PacketScan can do voice quality analysis based on packet statistics. So here we show you the mean opinion score on both sides of the call, actually. So audio going one way and audio going the other way. We can calculate the mean opinion score. If you need more advanced voice quality metrics, we have separate software for that support all the latest industry standard algorithms like PESC and Polka, which can do more rigorous voice quality analysis. Okay, we can delve deeper into the TCP traffic with a special program we've developed called TCP Analytics. So it'll analyze all the TCP traffic taking place over your network. It'll summarize it for you, all the open connections, closed connections, orphaned connections, top talkers, ports, you name it. It can save the TCP streams. You can zoom in on a specific TCP stream. You can identify. This is great for identifying like security incidents as well. If somebody has hacked into your network, there'll be a TCP stream going to some unknown IP address, and so you'll be able to see that here. So that's our TCP capability. In the interest of time, let me go ahead and move on. Key performance indicator. So we can set up a whole bunch of different KPIs. We can look at the call for calls specifically. We can look at how many successful calls, how many failed calls, how many calls per second. What type of error codes we're seeing, answered calls, unanswered calls, call duration, all sorts of stuff like that. So for call analysis, we can really break it down and get you all sorts of different graphs and so forth. Here again, we show you a distribution. Okay, here are all the error codes that happened over the SIP calls. Okay, so we see that the majority of the errors were other. But then there's some specific error codes that also showed up. Okay, we can look at things like SIP registrations, register messages, the distributions, deregistrations, registrations over time, successful registrations, failed registrations, things like that. They're all very nice, easy to digest graphs, color-coded, customizable graphs. You can save these graphs to a PDF and all that. And like I said, you can export the data to a CSV file. Yeah, I think here we're plotting things like registrations, deregistrations, and so on. Okay. All right. I want to conclude by talking about 5G. So we can do a complete analysis of the 5G core network. So the core network has all these different components, all these different interfaces, N1, N2, N4, N11, N20, N8, all these different interfaces. And basically we can decode all of these. So we can sit somewhere in the 5G network. 5G is all packet-based. And so we're sitting in the 5G network. We're connected up to a switch just like before. And we capture all the traffic and we can decode all of the different protocols traversing the 5G core network. So here's like an actual 5G call flow. So you see everything that's taking place in the 5G call. We build a call detail record. Then we can zoom in on that call. We can see all of the information going back and forth, setting up the call and so forth. Authentication requests and replies, registration requests and replies and things like that. Okay, yeah, thank you everybody for attending the webinar today. For more information, if you have any specific questions, please feel free to email us at info@gl.com. Thank you and have a good rest of your day or night or wherever you're dialing in from. Please enjoy the rest of your day. Thank you.